Now we are on the third question, that is considered the feedback rating. Smooth the rating using bean means with bean depth 3 illustrate steps. B. Suggest best way to detect outliers. C. Discuss other methods for data smoothing. Now, given feedback ratings, to illustrate, we use the sample list of student rating original sequence. So here we are using a sample list for a for student ratings. Okay, that is 54235144235551. Here are 13 ratings. So first, bean means smoothing with bean depth 3. That is step by step we are solving it. Okay. Step 1. Attach original indices and sort by rating. We keep original indices so we can map smooth value back to original order. Now, pairs before sort. Before sorting, we are making a pairs on which on the left side we are writing values, and on this side we are writing the index of that value. Now we are sorting the value in ascending order. Now step 2, group into consecutive bins of depth 3. In a consecutive way, we are writing this in 3 set of pairs. Okay. um, Pairs of 2 and the 3 pairs we are writing here. Okay. Bin 1, bin 2, bin 3, bin 4 and bin 5. In bin 5 we are only having one set because we are only having 13 ratings. Okay. Step 3. Compute bin means. Compute means digit by digit. Okay. In bin 1 means we are adding the values, and upon this we are writing the number of pairs. Okay. We are having 3 pairs, so we are writing 3 and adding the values. So answer we are having is 1.333. Bin 2 means here we are also doing the same. 2.667. Bin 3 4.000. Bin 4 5.000. In bin 5 we are only having one value, so we are writing 1 upon that and only the value, that is 5 upon 1. Step 4. Assign each bin mean back to the original indices of the items in that bin from the pairs above. Bin 1 means the answer we have calculated 1.333 and its original indices was 3, 6, 13 and 3. Bin 2 means 2.667. Its original indices was 9, 4, 10. Bin 3 means 4.000 and its original indices was 2, 7 and 8. Bin 4 means 5.000 and its original indices was 1, 5 and 11. Bin 5 means 5.000 and its original index was 12. So in step 5, we are what we are doing, that on the left side we are writing original index and on the right side we are writing that smooth value that we have calculated before. Here we are writing final smooth rating in that list. Now we will find the best way to detect outliers. First is IQR, that is also known as box plot rule, recommended as first simple test. Now compute Q1, that is 25% percentile, in Q3 that is 75 percentile. IQR Q3 माइनस Q1, IQR कैसे निकलेगा, जो Q3 में से Q1 को माइनस करेंगे. फ्लैग पॉइंट्स Q1 माइनस 1.5 IQR. ओके. ओके ओके. This is for lower bound and this is for upper bound. Illustration on our sorted data. On this sorted data, we are having 13 ratings. Now we will find the median using this formula n plus 1 upon 2. Our n was 13, so the median is 7. हाँ 7. मीडियन तो हमारा मीडियन निकलेगा 4. लोअर हाफ फर्स्ट 6 वैल्यूज हम लेंगे और Q1 मतलब इस पे मीडियन लगाएंगे, सो अपन our value is 2. Upper half, now the next 6 values we are taking Q3, now its median is 5. Now for calculating IQR we are minusing, we are subtracting Q1 from Q3. Now 5 minus 2, that is 3. Outlier bonds, bounds. We have already discussed that for a lower bound, we are having a formula q1 minus 1.5 IQR. Lower bound value is minus 2.5. Upper bound q3 plus 1.5 IQR and its value is 9.5. Now, modified use as z-score using MAD. Here we are compute median and MAD. Firstly, we will compute median and then mean absolute deviation. Now, modified z value, here is the formula, okay. Z is equals to 0.6745 multiplied by x minus median upon MAD. MAD is a robust to extremes. Here we are taking example. Median is equal to 4. MAD mean absolute deviation is 1. Okay, so here we are found out that it's not an outlier. Third, domain aware rules. This is the third one rule. Because ratings are bounded and often skewed, statistical tests can mix meaningful abnormal ratings. Use rules like a flag any rating greater than or equal to 2 when the respondent also gave low marks across multiple items or left a negative comment. Flag abrupt changes for the same student instructor over time. Flag rare extreme values when the class median is high. Other methods for smoothing are: first one is bean means, bean medians, moving averages, weighted moving average. Okay, so these four are the other methods. Bean means process that simple and reduces variance within groups and preserve overall distribution if you sort first. And its consists can blur sharp transition sensitive to how you choose beans. Second, bean medians. Replace each bean with its median instead of mean. And this we replace each bean with its median instead of mean. Its pro is uh, means its advantage is robust to extreme values inside beans and good for skewed or discrete ratings. Third one, moving average, sliding window. For ordered data, replace each value with mean of neighbors. Pros is conserves temporal trends with smooth noise. Its cons is introduce lag and can blur real sudden changes. Weighted moving average, exponential smoothing. Recent observation weighted more heavily. Its pros is responsive to change, simple hyperparameter. Cons is parameters need tuning. So come to question 12. In data integration for MCA, MTech analytics, discuss schema integration, handling redundant data, and resolving conflicts in values. So, when you combine feedback or workload data from multiple sources, three main problems generally arises. First one, schema integration. Second, redundant data and conflicting values. So in schema integration, the problem is different source uses different attribute names, types or structures. Steps to solve. Schema matching and mapping. Building a mapping table that aligns equivalent attributes. Harmonization. Convert types to common representation. Strings to categorical, numeric strings to numbers, and unified date formats. Canonical schema, master data models. Decide a single canonical schema and map all incoming records to it. Okay. Now use ontologies and metadata. Document meaning, allowed values, and provenance to avoid ambiguity. Handling redundant data. Problem is same student may respond to multiple surveys or a single survey may be submitted twice. Approaches. Deduplication rules. Define keys for identifying duplicates. Okay. uh, Composite keys like student ID plus course ID plus semester and drop exact duplicates. Record merging. Consolidation also called. When records partially overlay, merge using priority rules. Source weighting. If duplicates from different sources exist, weight responses by source reliability and sample size. Key provenance, retain metadata, so merged decisions can be audited. Now, resolving conflicts in values. So the problem is two sources give different values for the same attribute. So conflict resolution strategies are timestamp, a recency rule. It prefers the most recent entry. Authority rule, prefer values from higher trust sources. Aggregation rule, if both are plausible, store both and compute an aggregated value. Human in the loop, surface high confidence conflicts for manual review, flag suspicious conflicts. If difference is greater than threshold, mark for reconciliation, reconciliation, validation and monitoring, automatic validation, range checks, consistency checks. In automatic validation, we check consistency and range. Anomaly detection, detect outlier entries that may be data errors or provenance and audit trails is never overwrite raw data permanently. Keep raw plus clean versions. Okay, so question third is discuss normalization methods. A. Min max normalization. So the here is the formula that x minus x mean upon x max minus x mean maps original to 0 1 0 1 0 1. Its pros is simple, preserve relating, ordering, interpretable, and its disadvantage is sensitive to outliers. Now here is the formula for z-score normalization. Its advantage is it centers to mean, unit variance, and good for algorithms assuming normality. And its disadvantage, sensitive to outliers. If distribution is highly skewed, interpretation is harder. Here is the formula for z-square using mean absolute deviation. Now its process, MAD is more robust than standard deviation to extreme values, gives robust standardized scores. Cons, less common than as standard deviation biased Z scale differs, so cutoff thresholds must be adapted. D. Decimal scaling. Here is the formula for decimal scaling. Choose integer j such that max j less than 10j. Pros. Very simple, keeps relative order and reduces magnitude. Its cons is arbitrary depending on magnitude, not suitable to make distributions comparable across different ranges. Question number 14 is normalize the following faculty workload values. Here is the given values 200, 300, 400, 600 and 1000. Okay, so we have already discussed the formula for mix max normalization. Now we are putting the formula here. We are having x mean as 200, x max is 1000. Now we are putting the formula and we will compute each value. For 200 we are also calculating 300, 400, 600, 1000. So we are having a min max result in this list. Z-score normalization. Firstly we compute mean and sample standard deviation. Now we will now we are calculating the mean. Okay, so the mean we have calculated is 500. Now putting all the values in this standard deviation formula. So here is all the calculations. Now z-score using mean absolute deviation. Here firstly we will compute MAD, that is mean absolute deviation. We have calculated absolute deviations for every value. Now we will calculate MAD, that is 240. Now scaled score is here we are calculating the values. So the answer is in this list. D. Decimal scaling. Find J such that max x is less than 10. The maximum absolute value is 1000. Using the conventional formula, we have calculated the value 3 and divide each value by 10 to the power 3. Now we are dividing every value with 1000. Now the decimal scaling result is in this list are shown. So thank you.